Okay, everyone. I wanted to start with SOL review packet number 2. This was covered in the review session after school last Thursday, before school got out. So I wanted to go over these. Some of this stuff is going to seem a little new to you. We've touched on it. We haven't talked about it extensively. We will be going over a lot more of it. But hopefully, it will help you all along the way. Now, when we talk about relations and functions, a relation is just a set of ordered pairs, and the domain is the set of x values, or we can also call them input values. And the range is the set of y values, which we also call output values as well. Okay? Um, a function is a relation with no repeating x values. So when we list a relation, we can determine whether or not it is a function if we see there are any repeating x values. We can also check by looking at the vertical line test as well. So I wanted to kind of show you how I go about doing this. When I'm looking at a function, I'm going to name my x values, remember, is my domain. So what I do when I name my domain, when I have just specific points or ordered pairs, I name them individually. So here, my domain is, I have an x value of -1, an x value of 2, and an x value of 5. The -1 repeats, okay? So I'm not going to state it again. I'm only going to state it once. My range is just my y values, which is 7, 3, 0, and 2. And because these x values repeat right here, and they have different y values, that tells me it is not a function. All right. Now, when I look at these, let's look at these as far as ordered pairs. This point right here is the point -3, 2, right? Make sure you can see that really well. -3, 2. And then this is -2, 1, 2. So this is -2, -5. And then this is -1, -1. And then this is the point 1, -1. And then this point is 1, 2, 3, 4, 0. So 4, 0. Okay? So that's the easiest way that I start figuring out what my domain and range is. And what's kind of nice is when you do this, your x values are here and your y values are here, and that gives you your domain and range. So my domain is -3, -2, -1, 1, and 4. And my range is 2, -5, -1, -1 again. I don't want to repeat it. I just mentioned it once, and 0. Now, your range values, your y values can always repeat, okay? So this is a function because each one of these points has a separate x value. So this is a function, okay? Now, when I look at this here, I'm looking at a relation or a Venn diagram. So what I see here is, again, the easiest way to do this is to list them out as points. So this is the point 4, 2, and then 4 also goes to 5. 6 goes to -1, and 7 goes to 3. All right? Now, when I'm looking at this, this is a huge key that this is not a function. There's more than one number mapping from 4. And in fact, if I list them here, I have 4 repeating. Okay, so my domain is 4, 6, and 7. And my range is 2, 5, -1, and 3. But this is not a function because my x values repeat. Now, what about if we have a graph? A continuous graph is very unique because we can't name each and every one of these points because there's infinitely many points between here. Okay? So when I have a graph like this one right here, I have to pay attention to, do you see how this is an open circle? That means this point is not included, but let's go ahead and write it down. This is the point 1, 2, 3, 2. So this is 3, 2. And then this point right here is -1, -2, -3, 0. So this is -3, 0. And then I look at my uppermost point and my lowermost point. So I go up here 1, 2, 3, 4, 5. So this is -1, 5. And then here I have 1, 2, 3, 4. So this is going to be 1, 4. Now, when I mention the domain and range, I have a range of x values, okay? Here, I'm going to look at my lowest x value and my highest x value. So as you can see, my lowest x value is -3, and my highest x value out of all these points is +3, okay? And then I'm going to use inequality symbols to help me determine that domain. So x, it includes this point, so it's all the points greater than or equal to -3. However, it doesn't include this +3, so it's all values less than 3, okay? Now we're going to do something very similar with our range, but we're going to look at our highest and lowest values of our y values, okay? So our lowest y value is -4, and our highest y value is 5. And as you can see, all these points are included. Yes, this one's left out here, but that still is included right here. It's part of our range right here. So it is still less than or equal to 5 and greater than or equal to -4. And the way to tell whether or not something like this is a function is the vertical line test. And the vertical line test is if I draw a vertical line through a graph and I only hit it through any point on this graph and I only hit it at one point, then it is a function. And that's the case for this one. So this is a function. Okay? Now, here is a huge key with this. Now, what you're going to notice is that this guy keeps going to the left and right forever and ever, okay? It seems to have a maximum y value at 2, right? And it has a minimum y value at -1. And our domain seems to go on forever and ever. So instead of saying that, we usually write down all real numbers, and this is the symbol for all real numbers. Now our range, this tells me it continues on this pattern. So remember, it has a high and a low value. The highest value is 2, and the lowest value is 1. And believe it or not, this is a function, okay? Now this one right here, let's look at this one. This one, we have an x value of -2, 0, right? Now these tell us that our y values are going to keep going up and down. We have a definite start, and it doesn't appear to end for the x values. So my domain is going to be x is greater than or equal to that low x value, which is -2. My range, however, is that this is going to continue off up and down forever and ever. Maybe at a slow pace, but it's going to keep going. So my range is all real numbers. Now, does this pass the vertical line test? It does not. Do you see how I hit this graph in 2 points whenever I draw a vertical line? So that is not a function. Okay. So that's basically domain and range of continuous and non-continuous functions. Okay, so I want to kind of go over, let's see what else we have in here. Sorry guys, I just want to look real quick. Okay, so here I want to go over function notation. So we're given a function right here where it says, the way we pronounce this is f of x is equal to negative x minus 7. And they say, okay, find f of negative 5. All right. Now, what I have to do is I'm plugging in this negative 5 into my x value. So the way I would do this is f of negative 5 is equal to negative times negative 5 minus 7. All right. And this is where you need to be careful. This becomes a positive 5 minus 7, and that's equal to a negative 2. So f of negative 5 is equal to negative 2. Okay, so what it's saying is, what is the value of this function when x is equal to negative 5? That's all it's asking. Okay, so this one, here is our function. What is our value of our function when x is equal to negative 2? So the way I do this is I plug in negative 2 into my equation. Now please be very careful and plug it in. Now remember, when you do this, you could also use your calculator for this and use your store key for this. So this is 4 plus 4 plus 11, so that's 19. Okay, but let me show you what you can do with your calculator. It's a huge tool for you. Okay, so remember how we use the store key to store certain values into our calculator. Okay, so here, let's look at this. We have f of negative 5, right? So we're going to say, okay, negative 5 is going to be our x value. So I'm going to press negative 5 and press my store key, and then I do alpha x. And where is my x? Right here. Okay, so that tells me that I am storing in the value of negative 5 for x into my calculator. So then I just type out this. I do negative, and then I'm going to do alpha x minus 7. And you'll see that I get a negative 2. I'm going to get my other calculator so you guys can see it better. Okay, let's try this one. Okay, so let's look at this one right here. So they're telling us, what is the value of this function when x is equal to negative 2? So I'm going to store the value of negative 2 into x. So I do negative 2, and I press my, I'm going to zoom out for a second here so you guys can see the buttons that I'm pressing here. Eesh. Sorry, guys. Sorry. All right. So I'm going to do negative 2,